All right, perfect. All right, everybody, welcome to your first group tutoring session for the ASVAB. My name is Anderson. Welcome. We're gonna get started right now. This session is gonna run just about an hour, maybe a little over. I do respect y'all's time. I really want to get y'all out of here within 1 hour, but there's always, something, some little hiccup or whatever. You guys know the deal. But the thing is, y'all want to be here. Y'all want to grow. Y'all want to get this practice, and it's free to you. All you got to do is spend some time. So with that said, I want to make sure that I maximize your time, but just be mindful if I do take another minute or two at the end of the session. Don't worry about it. I'm just here to make sure that you guys get everything you need. So with that said, guys, get excited. This is all about arithmetic reasoning and mathematics knowledge. So we're going to be going over one topic throughout this whole hour so that we can really refresh on it, really build on some confidence, and then we can leave here feeling like we learned something, feeling like, oh, if I see a question like this on the ASVAB, I'm not going to trip out because I'll know exactly what I need to do. And even if you run into a problem that you don't know how to do, I want to teach you what you need to do whenever that happens. So with that said, we're going to get started right away here. So first things first, with the chat box there in the chat box, tell me, have you taken the ASVAB before, yes or no? And if you have taken it, what do you think? What are your thoughts on it? Okay, cool. You guys have? All right. So what are your thoughts on the ASVAB so far if you have taken it? Do you think it was just ridiculous? Do you think it was, do you feel like you didn't have enough time? Do you feel like you learned a lot of those things, but maybe you should have paid attention back in the day? Like, how do you feel? Be honest. PCAL's dumb. It's hard. Just got to touch up on a few topics, right? It's not bad. You got to refresh. You took the practice test only. Gotcha. You took it twice. The first time was hard because you didn't study. Second time was easier, but you understood what to expect. I love that. Arithmetic reasoning is hard. Yes, it is. Yes, it is. I've taken it 3 times, unfortunately, and it's so unnecessary. The timing went too fast. You were slow. The arithmetic reasoning was hardest. Took time. The time took you off. Yep. Hey, guys, the test is split into those 2 main math topics. You guys understand it as arithmetic reasoning and mathematics knowledge. Here's the thing. Mathematics knowledge is that pure math. Like when they tell you, all right, solve the equation, 2x plus 1 equals 5. Or find this number in this triangle or whatever. Anything that has to do with straight up math, that's mathematics knowledge. Anything that has to do with reading word problems or going through context or looking at a situation and really assessing what you need to do before you put in some math, that's arithmetic reasoning. You're reasoning with arithmetic. So you're talking about numbers. You're talking about situations that involve numbers. Does that make sense, everybody? Because I want to make sure everybody understands that very clear difference there. Again, arithmetic reasoning, mathematics knowledge. Mathematics knowledge, pure math, reasoning, more so word problems. So give me a yes in the chat box if you understand that, because I want everybody to feel comfortable and learn something in one way or another here today. I bet, perfect. And that way it can help you prepare for each section. Because like if you're thinking about all the numbers that you memorize in terms of calculating, and then you go into arithmetic reasoning, that's not as important. Reading the context is important. Breaking the problem down is important. Knowing what to do is important. So with that said, what topics do you guys feel like you need the most help with? Like what specific topics? Like, because today is about percents. Arithmetic reasoning and mathematics knowledge, those are the broad tests. But what topics, like percents, ratios, area, perimeter, what topics are really tripping y'all up? So I see percents here given, ratios, rates. What else? Dividing without a calculator. I love that. Fractions. Distributive property. Man, y'all are word problems for sure. Yup. Fractions, distance, some more fractions. I saw another rate over there. I saw percents, long division. So that was division twice. And really what I'm doing here is I'm listening to y'all. I'm listening to your needs, because the next session, I'm going to take one of these and I'm going to do it for the next session. So this is what really participating helps you out with. More percentages. Okay. We're going to get to those percent word problems. Today is about percents in terms of just the mathematics knowledge part. Billy, I'm not going to answer that specific question right here. We're going to go ahead and work on this here and then get back to that. I got you. But before we begin, everybody, so thanks for that, because now I understand you guys a little better now. And I want you guys to know me a little better, because there's no reason for y'all to sit in the room for a whole hour looking at some dude that you don't even know. So I just want to express to y'all who I am a little bit outside of my love for burritos and puns, and just really show you a little bit about who I am and what I do. So I'm a teacher. I'm an educator. That's who I am. And how I educate, it comes in a lot of different ways. I educate on my Instagram page in terms of life tips and motivation. I've been doing that for a few years now. I educate in terms of helping people pass the SAT and the GRE. The GRE is like the SAT, but for your master's level, not just getting to college. I'm the owner of Duran Learning, this company right here, and I'm helping out with the ASVAB. I tutored high school students for 10 years. I'm the director of the Learning Liaisons, where I run the math department, where I teach teachers. Like I literally teach the teachers that teach you. So I've been doing that for about 2.5 years now, and it's been getting better and better and better. And more kids have teachers now because I've helped them pass their certification tests. So the same boat that you guys are on right now, trying to pass the ASVAB to get into the military, I've helped teachers pass their certification tests so that they can actually have a job in the classroom. I've helped people pass the GRE, which is going to allow them to get into the college of their choice to get to their master's and PhD programs. I help people get to the SAT so that they can get into college. I help people pass the ASVAB so they can get into the military. Everything I do is all about helping other people succeed, plain and simple. And so today is no different. I want to make sure that you guys feel comfortable. And what that means is ask questions. If there's ever a point during this session that you feel confused, or I'm going too fast, or you want me to repeat anything, I want y'all to know that you can ask questions. I'm not the kind of teacher that kind of just needs to get his words out and then just says, all right, we're moving along. Nah, I don't play that, all right? So go ahead, ask questions if you need to. You're not slowing anybody down, because I can promise you that if you have a question, someone else probably has that same question, but maybe too shy to ask. So give me a yes in the chat box if you understand that you understand that you can ask questions, that you can ask for help. That way everybody can feel welcome here. Because when it comes to teaching, the first thing that needs to happen is trust. So I want y'all to trust that you can ask me questions. Perfect. And now let's just go ahead and dive in here, because my number one rule is that you try every problem. All right. That is my number one rule. So the thing is, and I said this earlier before the session started, is that if you're not trying, you're really forfeiting the opportunity to grow. And I said it earlier, those who try and fail, they still have a lesson that they can learn, something that they can take, something that they can improve on because they understand where they're at. But if you're too afraid to try anything, you'll never know how good you are and what you need to do to get better. So with that said, with every problem in today's session, I need everyone to try it regardless of whether you feel confident or not. Because the point is to become confident. All right? Hey, no worries. If you're not willing to try, you're forfeiting the opportunity to grow. This is a quote that I made. If you go on my Instagram page, the Do More with Duran, you'll see all of those quotes that I make up. Some of them I take from the internet and I cite my source, but I just take a minute on every video and just explain what that quote means and how you can use it to better your life with just a little shift. Like the tiniest little change in your life can make a big difference down the road. So that's what my Instagram is all about, just helping you succeed through everyday things. So I see that some people can't hear us. So Darrell, I see that you can't hear me. I'm going to type into the chat box how to get your phone on there. But with that said, we're going to start off with a warm-up problem, and we're going to start off by just refreshing on how to convert between percents to decimals. So we're going to start off with this, and we're going to go through one by one. So Darrell, let me just go ahead. Everybody take a second, try these out. I'm going to type it into the chat box to help Darrell out, and then we will get to these right now. So hey, Darrell, or Daryl, my bad. All right. So let's go ahead and go over this. I know we didn't have a chance to do them all, and that's completely okay. We're going to do these together because the actual problems, the tough ones that I'm going to have y'all do alone, the drill practice, I want to get to that ASAP. So let's go through this. Converting percents to decimals. Everybody in the chat box, or I'm going to let everybody, I'm going to allow y'all to unmute yourselves. So go ahead, everybody. If you want to use the mic or the chat box, how do you know to convert percents to decimals? Some people say move the decimal over. That is absolutely correct. Now, everybody should, well, a lot of people do understand it like that they take the decimal and they just move it over two spaces. Now, Booster's saying, hey, divided by 100. Now, I like that one better because even though they're both correct, dividing by 100 is the true thing that's actually happening. Moving the decimal place 2 times is the same as dividing by 100. Emily, I love what you just said there because you're segueing me into what I'm going to say next. Everybody in the chat box, type it in. What is every percent out of? Like, what is the original or all of something? What percent represents all of something?
100.
100.
Right? 100. So here's the key, everybody. The key is that when you read a percent, it's out of 100%. So this is technically 16 out of 100. And the thing is, when you divide by 100, what do you do to the decimal?
By moving the decimal over.
Exactly.
To the one place?
And twice. Because we have 2 zeros. Since we're dividing by 100, which has 2 zeros, we'll move the decimal place over by 2. And that's it. But I need us to understand these standard sets of facts because it's going to come back around later on when we tackle these tougher problems. And the thing is, most of us grew up only knowing one way to do a problem. But I'm going to show you how, by knowing how to do it 2 or more ways, it's beneficial to you because you'll be able to think about it in a more creative way. Not just, oh, man, I memorized this. No, I don't want that. I want you guys to look at a problem and say, oh, I know what this means. Not, oh, it says percent, so I memorized the formula. I want you to be able to talk about it. So the answer to number 1 should be 0.16. And again, you just move the decimal place over 2 times for everything. So for 43%, again, same deal, 0.43. Because we took the decimal place and we went ahead and moved it over twice. And then next, for 5%, this is one that not everybody gets right because I want to make sure that we're moving the decimal place over 2 times. 2 times.
0.05.
So let's move that thing over 2 times. If I start here and I move it over once, all right, cool. But you got to move it over twice. So everybody, what do I fill in here?
0.05? 0.
Yes, exactly. 0.05.
Oh, wait, a quick question. How come we had to add a 0 or like before the 5? Like, I got that confused.
Yeah, right there?
Yeah.
Exactly. Go ahead.
So you see how you moved, you go over, for 43, you go over 2 because it's 100. Now it's only 1, so it's 5. So you still have to move, you still divide by 100. So once you have 5, you still go over 2 dots over. So it's 0.05 instead of the 0.43, you know?
Oh, okay.
Does that make sense?
Yeah, that makes sense.
It's only a unit digit. You don't have like that 10 digit there, right?
Yeah.
But there's a 0 there. If you don't see anything, there's a 0 there. And so it'll be boom, boom, and then you just mark the 0. Just like that. Because you know how like you can say 0.5 or 0.5? And let me just not use 5. That's a bad number to use right now. But let me say you have 0.7 versus 0.7. They mean the same thing, right?
Mm-hmm.
Yeah. So if you have your 7, you can have a 0.0007. That's still 7. But if you move the decimal place over, you're gonna have to show that 0.
Oh,
Yeah.
okay.
Yeah, you gotta show it to make it make sense.
All right. That makes a lot of sense.
Yeah, no worries. So who didn't always get that? I mean, and so thank you for being honest, Jaslyn. Thank you, because I want everybody else to be honest here. Who didn't have 1,000% confidence with that one? Yeah, Emily, exactly. It would be 50% if you only moved it 1 time. Exactly, not 5%. Now let's go to the 15%. Everybody, what's that going to turn into?
0.15.
0.15.
Exactly, 0.15. And then lastly, with 8%, that's going to turn into what?
0.08.
Exactly. Booyah. If you have 5%, it's like having 0.05 cents out of 100. Exactly. 5%, think about it, per cent. 5 cents is this. That's 5 cents, right? Percents are out of 100. Percent out of 100. That's the key there.
But wouldn't
So,
0.7 be 70?
sorry, one more time.
You put 0.7, wouldn't that be 70% because you didn't put a 0 in front of the 7?
Exactly, yeah. So if we have 0.7 or 0.70, those mean the same thing. These both mean 70%.
I get that confused late so much because I keep thinking it's like, oh, it's just 5, but I never think that way, basically.
It's all good. And that's what we're here for. Again, to understand where we're getting ourselves wrong. That way we can make that improvement to get better. Because if no one's willing to tell you that you're wrong, or if you don't know that you're wrong, you're going to keep making the mistake. So that's what this is all about. So with that said, how's everybody feeling so far about this little warm up? We're just warming up, but how are we feeling? Good, bad?
Good.
Good.
Feeling good so far?
Mm-hmm.
All right, good. Someone said confident. All right, I'm hoping that we can keep it that way before we get into these tougher problems. So let's go ahead and just kind of tune it up a little bit. Let's get it slightly harder. Let's talk about how do we convert fractions to percentages. Let's talk about that. Because the thing is, there's a way to do this. There is a way. And everybody, just basic fact that we're going to play off of is percents are out of what again?
100.
Yeah. Percents are out of 100. If I focus myself here to the 3 out of 10, let me just go ahead and so this first problem, 3 out of 10. Is that out of 100 right now?
No.
Nah, it's out of what?
10.
Right. It's out of 10 right now. We need this to be out of 100. So how do I turn 10 into 100?
Multiply by 10.
Multiply by 10.
We can multiply by 10, everybody. Exactly. So let me change colors here so I can make it make sense here. Actually, let me use green. And let me just multiply this by 10. But what's the problem with this right now? Only multiplying 10 in the bottom.
It's 3.
Yeah, do it on top too.
Exactly. Shout out to Sam for that first answer there. Yeah, we have to, whatever we do to the bottom, we do to the top. Whatever we do to the denominator, we do to the numerator. So again, just a real quick refresher here. This is called the denominator. And up here, this is called a numerator. And let me know if my handwriting is okay, just making sure that we're all good. And so again, whatever we do on bottom, we do on top. So we got to multiply that by 10 up top as well. So 10 times 10, that gives us that 100. We got what we wanted. But 3 times 10, what's that going to be, everybody?
30.
30.
Exactly. That's going to be 30. So we have 30 out of 100. So what percent are we looking at?
30%.
Yup, exactly. We're looking at 30%. Does that make sense, everybody, in terms of like looking at fractions and turning them into percents? That's good. That's good. So here's what I want to do, guys. I want to give you all the opportunity to work together to just solve these next two together, all right? So start off with 3/4. Use the chat box, talk to each other, and explain why, all right? And explain why. I'm going to start drawing some things out to give you a placeholder, but talk to each other. I'm going to give you all 2 minutes. Go.
75% for the 3/4. And for the 4 feet, it's going to be 80%.
If you do 4 divided by 100, it's 25. So 4 times 25 is 100. So you have to do 4 times 25 and then 3 times 25.
Or you can do it as like if you're doing a dollar bill. So 3/4 for $1 is 75. That's not a way you can figure that out, so you wouldn't have to do all that. You can just think, oh, 4/4 is $1, 3/4 is 75. It's 75%.
Mm. Wait, I'm confused. How do you get 25 over 25?
Because you have to add to 100. You want to get 100 to the bottom, so you have 100%, and then you have, which is 25, and then you have to add the 25 on top too.
Because if you think about a quarter is 25 cents, right? So if it's 3.25 cents, it equals to what? 75.
Yeah, that's correct.
And
Yeah.
that's why you would get that.
Oh,
Exactly.
okay.
And Chantel, you had it perfectly said. Just want to correct you said adding instead of multiplying. So just
Multiply. Yeah.
Yeah, you got it perfect. Exactly.
Yeah, that was my problem too.
I was like
Yeah,
confused. Like, how do you get 25? I was like, wait, isn't that plus 100? Like, I was so lost because the first one I get it, but
Because
the second was like,
none of those are out of 100.
oh, okay.
So
Yeah. So Chantel, I think what you're trying to say is like, you need to see the percent. You got to see it out of 100 because that's what the percent is. And so we can't see a percent if it's out of 4, but we know that we can multiply 4 by 25 to get 100.
yeah.
And remember, with fractions, if you're going to do something to the denominator, you got to do it to the top as well. And so that's why we're multiplying by 25 up top too, so that we can get 75.
So you're better explaining than we are.
I mean, this is my career, but I want to give you guys the opportunity to explain it too, because if you're talking about it, that means you're growing with it. Think about it. Anytime you talk about something, you remember that, right? Most times when you talk about like life things and friend stuff. So that's what I want to talk about.
Yes. So quick question. So it's like if the denominator is 10, then it will be like 10 over 10, basically. If it's like less than that, then you have to use like 25, basically.
Whatever number will multiply the denominator to get to 100 is what you're looking for. So
The
here,
way that I do it is I would do 100 divided by the denominator. So 100 divided by 4 is 25.
Oh,
Right.
okay. That's easier. Yeah, that's easier that way. That makes a lot of sense. It's quicker
here
too.
we did 100 divided by 10, and that was 10.
Mm-hmm.
And that's why we multiply by 10 over 10. So then what number would we use for 4 over 5 then?
20.
We can use 20.
Exactly.
Because
100 divided by 5.
45 again,
Yeah.
or 1/4.
So we have 20 on top and 20 down.
Exactly.
That would be 80 divided by 100.
That's
And the percent then it would be
80%.
Yep, and that would be 80%. So over here, this would be 75%. And over here, it would be 30%. Now, what about 1/4?
25.
25, right? And some of us are used to using these fractions, here and there. And so we can see that, hey, a quarter, we know what a quarter is. That's 25 cents. But hear that out again. A quarter is 25 cents. So that means that it's 25% of 100. So you can do it with mental math, or we can go about it, again, mathematically. We can say we need 100% in the bottom. So how do we multiply from 4 to 100? Well, that's when we do the 100 divided by 4. And that gives us 25. And if you need to do some long division, again, that's okay too. Because you can do 100. 4 can't go into 1, but it can go into 10. It gives you 2. Take away the 8. And then 4 into 20, that's 5. And so again, 25 is the same thing that you'll get. Because 1 times 25 gives you 25. Yeah, I'm glad it feels easy for you. Hey, I'm glad it feels easy. The goal here is to, again, warm ourselves. This is a warm up, so I'm hoping that we're not, assuming that this is how it's going to be on the test. But I'm trying to warm us up so that we can use these essential facts to get these harder problems right. It's all about discipline, guys. And the discipline here is getting things right, being able to talk about those little things. So let's go ahead and take care of 2/5 over here then. Let me move this down just a little bit. Let me just take 2/5 and just write it over here. So let's take care of 2/5. So someone who hasn't spoken yet, let's see if we can work together here and see where we need to go. So if we're trying to do this for 2/5, anybody who hasn't spoken or contributed yet, what could we do here to get to the out of 100?
Times 20.
20. That's right, Alexis. And iPhone, what's your name, boss? I think there's 2 people named iPhone, so I'm going to have to guess at who's talking.
Artavia is talking.
Who was that? Sorry.
My name Artavia. For the iPhone, my name's Artavia.
Oh, Artavia, hey, what's up? Oh, yeah, I saw you joining the group. What's up? All right, so here we are. And so we're going to do 20. All right, cool. Because 5 times 20 is 100. Or you can say, hey, what's 100 divided by 5? 20. So that's what I'm going to multiply. And let me change this color here so that y'all can see, because I might post these notes in my group. That way you'll have it.
Can I ask a question?
Yeah, absolutely. That was Bushu?
No, it's not me.
Oh, I got you. What question? What's up?
How do you deal with something like 13 divided by 16?
So 13 divided by 16, that would be a different situation. And now here's what I'm going to reveal to you.
Okay.
The ASVAB, who's taken it before? Do you get a calculator, yes or no?
No.
You do not.
No.
So here's the thing. The math that they get you, or the math that they will be having you do, it will not be ridiculous, right? It's going to be a lot of common math that you can use in everyday life. That's what they're going to give you. So something like out of 16, if they're going to say, oh, convert it to a percent, well, if it's 4 out of 16, let's think about it. Can you simplify this at all?
1/4.
You can. 1/4. 1/4.
Yeah, you can turn it into like 1 out of 4 because those are both divisible by 4.
Yeah.
Now, we know what 1/4 is though, right?
Yeah, 25%.
Exactly. So that's what I'm saying. When it comes to something like that, what you're going to do is say, hey, look, what's the relationship between the top and the bottom? Oh, 4 is 1/4 of 16. So 4 is 25% of 16. So that's how you can say it. So, but they're not going to have you convert, like, let's say, oh, what's maybe 11 out of 16, convert that to a percent? Very unlikely. Because that's going to come out to be a run-on number. It's going to be repeating decimal forever. So they're not going to ask you typical types. They're going to ask you things that you can apply. But with that said, that's warm-up number 2. We're going to start off with practice problem number 1 up next. But with that said, we're done with the warm-up. Give me a yes in the chat box if you're ready for the torture that's going to happen next.
Yeah.
I was the most excited I've ever heard in my life, man.
Yeah, I got a question before we move on. So say like you have a 1/8 to convert it to a percentage, right? So how do we do that in that case? So since
So with mental math, you can do it straight up or with mental math. So or with long division. So think about it like this.
right,
If I'm saying 1/8, divide 8 into 1. Because I can turn that into a decimal. 8 can't go into 1, but 8 can go into 10. One time. And then I'm going to subtract the 8. I got 2. How many times does 8 go into 20?
2 times.
2 times, right? Cool. So then I'm going to subtract that 16 because 2 times 8, 16. So I'm going to take that out. Now I got 4. Drop another 0. How many times does 8 go into 40?
5.
It goes in 5 times, yeah. So the decimal form that we have right now is 0.125. Think about it like this, everybody. How do I go from a decimal to a percent? If I go from a percent to a decimal by moving the decimal place to the left 2 times, how do I go backwards from decimal to percent?
Move to the right.
Exactly. We're going to do the opposite and go from left to right 2 times, which means that this is actually 12.5%.
Okay.
And so long division is another way that we can do it.
All right.
So it's not always just that simple technique of, oh, what fraction can we make it? We can do it multiple ways. Again, that's what I told you guys this session would be about, understanding it in multiple ways. Because once you have that in your tool belt, boom, you're going to be tackling these problems like it's just straight up cash. So with that said, I'm going to start us off on the first problem here. Here's how this is going to work. And pay attention, everybody. I'm going to mute everybody's mic. I'm going to time it for however long it's going to be. That first one, I think the first one I had set up for 1 minute and 15 seconds. I'm going to time it like that. After 1 minute 15, stop. We're going to do it together. The next problem, 15, stop, do it. I'm only going to ask you this. Do not reveal the answer. Do not share the answer until I say go, because I don't want anybody feeling like they're just going to sit back, relax, and wait for the answer, okay? I want everybody to try it out so they can grow, so don't reveal it. Say yes if you understand that, but you will not reveal your answer. I say. All right, perfect. So I'm gonna go ahead and set up my timer right now, 1 minute, 15 seconds. Alrighty, and that's at 15. All right, here we go. 3, 2, 1, go. No talking. I'm muting everybody. And do not reveal your. Hey, Astra, do not share your answer until I say go. All right, we're looking at 4, 3, 2, 1. Answers. What do we got? Type it into the chat box. What do we got? All right, we got 0.16, 30.8, 30.8, 30.8, 0.016, 30.8, 30.8. All right, let's go ahead and go over it then. So let's go over this thing here. So the question is, what is 70% of 44? So here's how I run things. I don't reveal the answer. I go through the work first so that everybody pays attention, and then you'll see the answer at the end. So we gotta be able to translate these statements. So now we're getting into a little bit of that arithmetic reasoning, because we got to break down sentences. We got to break down these words. So the question is, what is 70% of 44? So with that said, everybody, 70% of 44. What does that mean we're doing with the percent and 44? The word of, what does that keyword mean for us to do? Multiply. Yep, Alexa's got it there. It's multiply. And it's okay, Sam. It's not going to be divide. The key phrase for dividing is typically out of. So it's completely okay that we thought of it that way. But just remember, everybody, the word of by itself, like 70% of this or 2% of this, typically we're multiplying. If we say, hey, what's 10 out of 27? Oh, that's a fraction, 10 over 27. But the word of by itself means multiply, and the phrase out of means divide. So far, so good, everybody? So cool. So we have 70% multiplied by 44. Now, everybody, quick question. What's the problem here? Why can't I multiply the percent right now? Oh, and let me actually let everybody talk to you. Okay, so you guys can talk now. So what is it that...
Not in the decimal form yet? Like it's not equivalent to the 44?
Exactly. That's a great way to say it. It's not equivalent. You can't multiply two things that aren't equivalent. So you got a percent multiplied by a number. You can't do that. So I need to turn this percent to a decimal. All right, so turn into a decimal. And now with that, Bushi, I'm gonna go ahead and mute you real quick because it sounds like things are moving around in the background. But so we got this and we're gonna turn it into a decimal. The rule was, again, we just take that percent and we divide it by 100 because it's out of 100. The shortcut method, though, is just to take that decimal and move it over twice. That's that shortcut. Just move it over twice. So we got 0.7 multiplied by 44. So from here, are we ready to multiply now? Yeah, now we can definitely multiply. So when we think about it, let me just change the color here. When we try to do this and we got 44 multiplied by 0.7. The thing is, everybody, we just multiply straight up. But what's the thing that's going to happen at the end, though? What do we got to pay attention to at the end?
The decimal place.
Yeah, what's the decimal place, guys? Exactly. You're basically borrowing that thing. So you're going to do the problem as if it's not even there. And then at the end, you're going to come back and put the decimal place back. So you can think about it like this. For right now, I'm going to move the decimal place back so that it's 44 times 7. And then at the end, whatever number you get, you're going to take the decimal and move it right back. So just pretend it's not there and then bring it back at the end. Or, again, just multiply straight up and then just include the decimal place one number in because you only have one decimal place. Either way, let's get to it. So let's go ahead then and tackle it. So 4 times 7, we're going to start off there. Let me use a highlighter here. Start off with 4 times 7. That's going to go ahead and give us that 28. Can I write 28 though, everybody?
No.
And that triggered somebody. Yeah, you can't, obvious, right? So what do we do with that 2?
Carry it.
Yep, we always carry it. We always carry it. And just know that, everybody, I'm not trying to patronize anybody. I know a lot of us here do know how to multiply, but I always want to help us refresh so that if there's anybody at all that may need to hear it, again, we're all here to support each other. So thank you. So again, then we're going to do 4 times 7 now. That's going to give us the 28 again. And then the 2, what do we do with it?
You add it.
Right. So 4 times 7 is 28, plus that 2 is 30. So like we said, we got this answer, 308, but we were multiplying a decimal. So our job is to make sure that we keep that balance. We put it away for a moment. Now let's bring it back. So the answer should be 30.8. Who got it right? Okay, good stuff, Kathy.
Yeah.
Right on. And even if you didn't get it right, say no, be honest. Guys, look, it's important that you're honest with yourself because if you didn't get it right, then I want you to think about, hey, what is it that I messed up on? Was it that I had to convert first? Was it that I had to bring the decimal place? Was it just multiplying? Because when you identify what your problem is, then you can get better at it. Think about it with any sport. If you don't try, if you don't practice, then you won't find out what you need to work on. So think about this like practice before a game, before any sport. You want to find out. It's good to find out what you're bad at. So what does this mean, though? We're going to talk about this for a second, but this is something that not a lot of teachers do. What does 30.8 mean in this problem? Let's talk about it.
That's the result, the number result.
Correct. Now let's be a little more specific there, right? So 30.8 is...
It's 7%. of 44.
Exactly, Billy. Perfect. It's 70% of 44. And Emily, shout out. Yup. That is 70% of 44. This is 70% of 44. And I want to really point out what I just did there. Not a lot of people do this. When you finish a problem, usually you say, oh, I'm done. And you move on to the next one without reflecting. This takes 2 seconds to say, oh, there's my answer. This is what it means. I'm good. Let's move on. I need you guys to promise yourselves that you're going to do that. It's not about being mindless and just doing a bunch of problems. It's about reflecting on each problem ever so slightly so that you can, again, feel more confident and comfortable with it. I'm telling you right now, we can do 5 problems over a 2-hour period and get more out of that than, let's say, 20 problems in that same time period if you're just rushing and blasting it, because you're actually being intentional about the steps. So with that said, I'm going to time this again. 1 minute, 15 seconds. 3, 2, 1. Let's go. I'm going to mute everybody again. And remember, make sure to not type your answer. Three, two, one, go. Answers. So one person that says 57 points. So we have a couple different answers here. 57.6, 49.1, 6.30, 60.3, 6.03, 60.3. All right, so let's go ahead and really think about it in this way. So anybody who have any of these answers or any other answers, let's talk about this thing called reasonableness. Like, how reasonable is it that you got your numbers? So here's what I mean. 90% of 67. If we're talking about 90% of any number, would you agree that 90% is pretty close to what that number actually is? Right?
Yeah.
Like, if you have 90% of something, you're almost at 100%, right? You're almost at the whole thing. So would it be agreeable to y'all to say that 90% of 67 should be pretty close to 67?
Correct.
Right? That's pretty agreeable. So when we take a look at these 4 answers, I just want to make sure that when you get your answer, like let's say we got 6.30, is that reasonable in terms of being that, close enough to 67?
No.
Right. So again, I'm not trying to make anybody feel bad. I just want to expose you to, hey, checking our work at the end and asking ourselves, we were supposed to get 90% of this. Are we close to that number? Because 90% is really close to 100. So is the number that I got close to the original? Nah, it's not really that close. So maybe I need to go back and check my work. That's all that means. But let's just go about it. Let's go about it straight up. So with this 90% of 67, what I can do here, I'm going to show you 2 ways to do this. The first way is that way that we set ourselves. We're going to straight up say 90% of 67 translates. The of is multiply. 90%, we got to translate that to a decimal. And like we always say, that's going to be 2 decimal places to the left. So you can write 0.9 or 0.90. Either way is fine. But in terms of making it easier when you're going to multiply it, everybody, I would honestly say, don't write any extra zeros after that last number. It's not really necessary.
I have a question.
Absolutely, Chantal, what's up?
I do a little different. I don't know how, but I think I watched a video where I canceled the 0 from 90 and I put a decimal in the 67, and then I do it like that. But I still get the right answer. If that makes sense.
Oh, so you're saying you take it, you make it like 9% of 670. So you took one decimal away here, put it there.
Yeah, so I do 9 times 6.7.
Oh, okay. No, I see what you did. Okay, so that is absolutely correct. If you understand it that way, perfect. That takes a little more time to explain it the right way. So
Yeah, I'm just making sure.
Yeah.
All right.
I got you. Yeah, good stuff though. That works. So here we have 0.9 times that 67. And so we're just going to go about it that way. 67 times 9. And then we're going to bring that decimal place back at the end. So 7 times 9, that should give me 63. Carry the 6. Then 6 times 9 gives me 54. And then you're going to add the 6 back. So 54 plus 6 gives me 60. So that's 603. But remember, you signed a contract here. You said, hey, I took that decimal out. Now I got to put it back in. So my official answer, 60.3. Hey, right on. That's what's up. You got it right. So who else got it right? And if you got it wrong, be honest. Where was it that you went wrong? Was it converting? Was it the multiplying? Did you just multiply wrong? I want you to talk about it. What did we do right? What did we do wrong?
Okay, so I realized I lined up my multiplication problem wrong.
I'm sorry. I'm having a little trouble hearing you. It sounds like you're cutting in and out.
0.980, but the 9 was under the 6.
Hey, Deja, I'm sorry. It's cutting in and out for you. Do you want to go ahead and
Okay, so when I multiplied, instead of multiplying 67, okay.
Yeah, my bad about that. Yeah, go ahead and type that into the chat box, please. No worries though. So Jaslyn, you said you got it wrong. So go ahead and unmute yourself. Where was it that you found the correction to be made?
The way I did it basically is was like I start with, let's say 7 times 7 will give you 49. Then I added with 7 since it's like a short way to get the accurate answer for 7 times 8. I did so I added 49 plus 7 will give you 56, and then the same thing with that will give you 63. So afterwards, when I find out what 7 times 9 will give you 63, so I'll put 3 down and add 6. So that part got me messed up. Before thinking like it's by by 6 times, but I was like, wait, no, it's 7 times. So I was like, I had to add it by 7 as a result. So if I use 7 times 6, which give me 42, if I added plus 7, will give me 49. It's the same way as saying 7.
Using that logic, you're using reference logic. So you're
yeah, basically.
To another. I got you. So that's actually a really good technique if you have the basics down. So that's an advanced technique, and I really appreciate you trying that out. But we got to start with the basics to understand how that works truly. So you have a starting understanding of that, and that's cool. But I would really recommend
because like I try to do the basic, but somehow was like I get confused with all the numbers, and I had to like do it the long way just to get the answer. So I was like, so I end up using the other method to see if it's the same way.
I got you. No worries. Hey, that's fine. All right, so everybody, let me go ahead and show you another way to do this in terms of mental math. So here's what I mean. Check this out. We got 90% of 67. What percent is left? Like to get to 100, from 90 to 100, what percent is that, everybody?
10%.
Correct, right? 10%. So let me do it. This is a way you can do it too. You can say I can take 10% of 67 and then take it away because that'll give me 90%. Let me show you right here. This is going to be easy because 10% is saying 0.1, right?
Mm-hmm.
So when you multiply by 0.1, there's actually a pretty nice trick to this. Multiplying by 0.1 is like the same thing as dividing by 10. When you divide by 10, what do you do with the decimal place?
One place to the left.
Exactly. So this is something that we can easily recognize because, again, 10% is just times 0.1. And if we multiply by 0.1, we're just taking that 67 and turning it into 6.7. So this is 10%, but we want 90%, not the 10%. So if I were to do 67 minus 6.7, I would get my answer. And watch this. I'm going to put the decimal place and a 0 here. Because remember, there's always a 0 there. We just don't write it all the time. So let's get to it. 0 minus 7. Can't do that. We got to borrow 1, right? And so then 10 minus 7, everybody. Loud and proud.
3.
Boom. Then next, and there's a little delay, and I was like, and then we have 6 minus 6, that's going to be 0.
Yeah.
And then 6 drops down and gives us 60.3.
Oh,
Is that the same answer?
yes. It's quicker and more easier that way.
Right. And all I'm trying to expose you to is the idea that you can do it in more than one way. All right. This is called logic. You're thinking about this logically. If I want 90%, then I can take away 10%. Or I can multiply it by 0.9. Exactly, Deja. You can just multiply it by 0.9, or you can subtract the 10%. So find the 10% first and then take it away. Both ways work. Sometimes you'll be able to do one way mentally a lot faster. So question number 3 is coming up. 1 minute, 15 seconds, guys. How are we feeling so far? I don't like that idea. I'm going to stick to multiply by 100.
Boy.
That's totally fine. Totally fine. Who's ready?
I just hope my brain doesn't fry so much.
Can you keep it up real quick?
I'm not going to lie.
And if you want to take a screenshot or anything, guys, go ahead. Grab your phone. You can take a picture. I don't mind. I don't mind at all. And I'm going to post this video, the recording, in our Facebook group. And I'm also going to post the notes in our Facebook group.
I'm not going to lie.
Yeah. He said, I'm not going to lie, but then. All right, bet. So here we go. 3, 2, 1. I'm muting everybody. And go. Three, two, one. Answers. What do we got? Type it in, type it in, type it in. 71.2, 71.2. No, it looks like we're getting a little more confident here. Look at that. We went from a lot of us kind of, being here or there to really now we're coming together. Look at this. Guys, this is what trying does. This is what attempting things does. This is what letting go of your pride does in terms of understanding how to do it the right way. Sometimes you just got to get it wrong to get it the right way. And even if you're not there yet, I bet you there's something that you can point out that you need to work on. I bet you there is. So let's go through it. 80% of 89. What we want to do is translate that statement first, because just like I think it was Emily, that these aren't the same units to multiply. Percents and numbers, no, you got to turn them into the same type of number. So that's why it's necessary to turn that 80% into 0.80. To make my life easier, I'm just going to take away that last 0, because 0.8 and 0.80 is the same thing. Same thing. Now, up next, that of, remember, the word of is multiplying. And I'm going to write that over here. Out of, that means divide. All right. So the word of translates to multiply. The words out of translates to divide. So here we have 89. And now we're going to get our thing done here. We're just going to get it done. So 89 multiplied by 0.8. All right, so I'm going to move that decimal out and then bring it back at the end. 9 times 8 gives me 2, 72, and I'm going to carry that 7. 8 times 8 gives me 64. With that 7 that's carried, add 7 to 64 to give us 71. And just like we said, we had a contract, got to bring that decimal right back. So that's 71.2. And there we are. Now
Can you say
again,
the other way?
so the way with subtracting
With
that
the
percent
10,
out?
like with the 8%, like it's like with 20% away from 100, right?
Yeah, I got you. Yeah, I'll do that right now too. Yeah, for sure.
Yeah.
But before I do that though, really quick, guys, what does the answer mean though? Remember, talk about what the answer means. What does this mean?
71.2 of 89.
It means 71.2 is 80% of 89.
Exactly. That's how we do it, guys. So here's the other way, and this will be the last problem because I do respect y'all's time. So let me just go through this here, and I'm gonna post this into the group, so you're gonna have access to the rest of the problems. I'm not gonna shortchange y'all like that. All right. I made 10 problems because I knew that I wasn't gonna get through all of them, but you guys get the rest easy. So here's the thing. The other way that we can go about it is again playing off of 100%. So we're 20% away. Now, it may not make the most sense to do it here because 20% is definitely going to be, not a common number, right? It's not very common. So we can still do it though. It'll just take a little more time. So here's how we can do it. Oh, sorry, someone speaking? All right, no worries. So I'm going to go ahead and find out what that 10% is. And that's going to be 0.1 times 89, which gives me 8.9. Again, that's 10%. So if I double that, that'll be 20%. So what happens if I multiply this by 2? Well, that's going to give me 9 times 2 is 8. 8 times 2 is 16. That's 17. From there, we're going to subtract 89 minus 17.8. So do we see how this can be a little more complicated now if it's not a convenient number? Mm-hmm. So that's the idea here. This is not terribly convenient because, again, there's more work than we need to do here. Like we just did one operation, then we did 2 operations, then this is the 3rd operation. But the thing is here, this is just one operation. So when it comes to 10%, it's convenient because it's mental math for the 10% and then come back. The reason I multiplied by 2, and sorry for not saying that clearly, my bad, is that over here, we said that 10% of 89 was 8.9, and that's 10%. To get 20%, we got to multiply that by 2, because if you multiply 10% by 2, you get 20%. So does it make sense, Daryl?
Yeah.
Sweet, man, thanks. So there we are, and then we're coming back here, and we have 20%. Again, this was 20%. So you take it away to get to the 80%. And so just write it out, borrow the 1. So then you have 2 here. Then 8 minus 7 is 1. 8 minus 1 is 7. And look at that. You still end up with the right answer. So what I'm trying to say is, in any problem that you do, before you do it, if your plan makes sense, go with it. Go with it, because you're guaranteed to get the right answer if you think about the plan beforehand. How often does it happen to us, everybody? When we read a word problem or something and we freak out instantly, we literally pick up our calculators or just try to start scratching numbers together, hoping for the best, because we freak out, especially when we see decimals, especially when we see fractions, right? We freak out. But with the discipline of reading the problem first, breaking down the words that you see and saying, hey, this means this, and we're going to have to do this to get there, it gives you that foundation to set things up. It's kind of like this, everybody. Think about it. Have you ever seen anybody build a house before building the blueprint first? You ever seen anybody just try to build a house from scratch? Does it really work out?
No.
Nah. right? Never really works out. And so that's the thing. You got to lay out your foundation and your blueprint before you end up building a house, because that's how ultimately the house is going to stand. So with that said, everybody, again, there's more problems to go through. You're going to get all of these. You're going to get all of them. I'm going to post this into the Facebook group. So if you're not in there,